All right, so here we're going to talk about simplifying radicals, and I am combining two sections, 7.1 and 7.2. So let's start with talking about what everything means in the radical. So the index would be that 3, so whatever that little number is there in front of the radical. The radical symbol is the symbol in between the 3 and the 8, and then what's inside the radical, we call it the radicand. All right, and before we begin, sometimes it's useful to know our perfect squares. So we're going to go ahead and write those out. All right, so perfect squares are the numbers you get when you square a number. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, and you could keep on going and doing that forever, and these are your perfect squares here. So again, we're going to be using that to simplify. So let's go ahead and start off with the first one. We have 36, and you could rewrite 36. You could use a tree as 6 times 6. And once you find a pair, you could go ahead and circle that together. So we have a pair of 6s, and that would come out of the radical, but it would just be 1 6. So each pair, it comes out as just one of those numbers. Okay, and then the square root of 0, you should just memorize that that's just 0. So now let's do C, 120. I'm going to go ahead and do that up here because I feel like I need a little bit more space. So you want to think of two numbers that multiply out to 120. So that's going to be 10 and 12. And then think of two numbers that multiply out to 10, which is 5 and 2. And then maybe 2 and 6. And then you could break 6 up into 3 and 2. So again, you want to find any pairs, so like matching, so you match these two, and then you have a 5, a 3, and a 2 left, so those don't have a pair. So you're going to go ahead and whatever doesn't have a pair, it's going to be inside the radical. So 5 times 3 times 2, and then whatever has a pair, it goes outside, but remember, each grouping, you only take one of those out. Okay, and then you just simplify. So 5 times 3 times 2, that's going to be 30. So this is 2 rad 30. All right, we have the next one we have is a fraction there. So we'll go ahead and do that over here. So if you remember, 0.25 is the same thing as saying 1/4. And this one, the way you want to break that up is the square root of 1 is just 1, so that's going to be on the top. And then the square root of 4 is just 2. And we'll get into more of this in the upcoming sections. So this is just 1/2. All right. Next, we're going to talk about finding the roots of a cubic. So a cubic or cube roots. In this case, we're looking for groupings of 3. So what do you think these indexes before were? They were 2, right? So even though it doesn't say, those indices were 2, and that's why we're doing groupings of 2. All right, so what number can you multiply 3 times and get 1? Well, 1 times 1 times 1, so this would just be 1. Okay, then we're going to do the next one. 3 square root of negative 64. That's going to be, you could do negative 8 times 8. Then you could break that up into 4 times 2. And 4 times 2 again. And then 2 times 2. and 2 times 2. So, and then you could just, that negative, whenever you have an odd indices, is always going to come outside of the radical. So I'm just going to go ahead and bring that outside. Okay, and then what we have left is, remember you're looking for groupings of 3. So here's a grouping of 3 2's. Here's another grouping of 3 2's. And then these ones, I already split them up, so I like to just cancel them out. So you have 2 groups of 2's. And you're going to go ahead and write those out on the outside. So that's going to be one of them, another one, and there's nothing left over, so there's nothing left inside the radical. So this is -4. Now, how could you check? Well, if you check because we got nothing left inside the radical, if we do -4 times -4 times -4, that should be -64. And yes, that is. Okay, so this would be -4. Okay, then we have C, which is 8, cube root of 8. So you could do a tree or you could think about it. So what number, when you multiply it 3 times by itself, does it give you 8? So 2 times 2 times 2. So I know this is going to be 2, but let's go ahead and work it out. So we have 4 times 2, and then 2 and 2, and we broke this one up, so I'm going to cross it out. So here we have one group of 2, and so that's why the answer is 2. And we have nothing left over, so there's nothing left inside the radical. Alright, so next we're going to talk about exponent rules. So here are these exponent rules. If you want to pause the video and write them down. So we have product rule, quotient rule, power rule, and power of a product, power of a fraction, zero exponent, negative exponent, and fractional exponent. So again, pause the video and write these down. So we're going to be using those to simplify, and the first one we're going to be using is actually the fractional exponent here. And so as we'll do the first example, I'm just going to go ahead and write it up here. And I'm going to go ahead and zoom in. Okay, so we want to go ahead and rewrite this. This would be rational. And then this is equal to radical. So we want to write it in a radical format. So 4 is inside the base. And then the denominator is your index. And then your numerator is what you raise your power to. And remember, this is just square root of 4, which is 2. Okay, now let's try it for the next one. So 4 is going to be what's inside. And then your denominator is your indice. And then your numerator is what you raise your base to. So that's going to be 4 to the third. Okay, then you could rewrite it as 4 to the third, which is 64. And then you could go ahead and do a tree. So I'm going to do that tree on the side. I know 64 is 8 times 8. And then that's 4 times 2. 4 times 2. 2 and 2. 2 and 2. And then I'm going to like just to cross out what I've already used. So now we're going to do groupings of 2, right? So here's a grouping of 2, here's a grouping of 2, and then this 2 and this 2, we could group those together. So we don't have anything left over, but we do have 1, 2, 3 groupings of 2. So 1, 2, 3, 2 times 2 times 2 times 2 is 8. And if you memorized it, the square root of 64 is 8. So you could just memorize 2. Alright, next we have b to the 1/3 and then b to the 5/3. So I'm just going to go up. And we're going to go ahead and use this right here, which is product rule, we add the base's exponents. So that means this is b 1/3 plus 5/3. Now you have the same denominator, so that means you could add your fractions, and that is b plus 6/3, and then 6/3 is 2, so that's b squared. Alright, and the last thing we're going to talk about is multiplication. So here we have a z to the 2/3 on the outside, and we have a binomial. So what we're going to do is we're going to distribute it using this distributive property. And that's going to give us z to the 2/3 times z to the 1/3 minus z to the 2/3 z to the 5th. And so what we have to do is we could add these bases. So these have common denominators, so that becomes z to the 3/3. But then over here, you need to get common denominators. So that's going to give you 3/3. And then this gives you 15/3. And then you have to add that with the 2. So that's minus z 17/3. And then that's your answer. You can't simplify that anymore. Okay, next we have a binomial times a binomial. So if you remember, this is the box method. And so I'm going to go ahead and draw a box. And then I'm going to write x to the 1/3 here, -5, x to the 1/3 here, and 2. Okay, and then I'm going to go ahead and multiply. So that's going to be x to the 1/3 times x to the 1/3, -5, x to the 1/3, 2, x to the 1/3, and then -10 here. Okay, then you're going to notice these are like terms, so we could go ahead and combine those because they both are x to the 1/3. And then here you could add the exponents. So for the first one, you get x plus 1/3 plus 1/3. And then we're going to combine those like terms that I circled. So that's going to give you a minus 3x to the 1/3 and then minus 10. And then these, you're going to want to add those. Since I already have common denominators, I could just go ahead and add those. So that gives you a 2/3 minus 3x to the 1/3 minus 10. And that would be your final answer.